Hi friends, welcome to SR Physics Academy. Today we are going to discuss about spectrum and types of spectrum. So, spectrum means what? A band of colors are seen in a rainbow, produced by separation of the component of light by their different degree of refraction according to wavelength. Here we will, yeah. So in this, look at this image. Here ordinary white light consists of waves, all wavelength in the visible range. This is why when white light is passes through a spectrum, so here passing the light through a spectrum, a series of colored bands are seen called spectrum. As the full spectrum of visible light travels through a prism, the wavelengths separate into colors of rainbow because each color is a different wavelength. In this case, first we will take violet. So violet has the shortest wavelength, around we can say that 380 nanometer, and red has a longer wavelength at around 700 nanometers. Next we will discuss what are the types of spectrum. First one is continuous spectrum and line spectrum. The line spectrum, another name is atomic spectrum also we can call. First, what is continuous spectrum? So in this kind of spectrum, the boundary line in between the colors cannot be marked. The color diffuse into each other. So what it is this means spectrum line, what did you understand? Since the colors merge into each other, means violet merge into blue, blue into green, okay, continuous so on. So we call it, what do you call, continuous spectrum. When this light is passed through an object, the wave with the shortest wavelength, we can say that shortest wavelength, it is a last means we discussed shortest wavelength means violet, deviate the most than one in the longest wavelength is red. So what is continuous spectrum means one color merge into another without any dark space. This is the important line, the important point, the continuous spectrum. Okay. So one color merge into another without any dark space. The best example we can say that rainbow. Next, another spectrum type of spectrum is line spectrum or atomic spectrum. Here, when atoms are excited, they emit light of certain wavelength which correspond to different colors. The emitted light can be observed as a series of colored lines with a dark space in between. This series of color lines is called line or atomic spectra. Each element produces a unique set of spectral line also. So here color lines with a dark space. Okay, color lines with a dark space or spectrum with black lines also it will come. That is we called as line spectrum. Now even atomic spectrum also two type. First is atomic absorption spectrum is there and atomic emission spectrum is there. So look at this image here, the interaction of electromagnetic radiation with matter. Okay, here it is for example this is some matter is there, okay, unknown matter. So the interaction of electromagnetic radiation with the matter, this is electromagnetic radiation, causes the atom and molecule to absorb some energy state. Okay, so in this case what happened, so here I am taking the ground state. Ground state means E0, next state is E1, E2, E3 as well. So in this case, so here E0 means some E1, some electrons are stable. Even E1 also the particular energy that electrons are stable. E2 also particular, each E1, E2, E3 all elements are there according to their energy level, they are stable. So in some particular cases, the interaction of electromagnetic radiation with matter causes what happens, here the atom and molecules get some disturbance. Okay, so in this case what happens, these electrons are getting what, stable to unstable condition here. So that it is the need to, what is that, will be jump to one place to another. So here this electron jump to lower level to high level, we can say that it is an absorption spectrum. So when that jump from lower to and it produce some what, radiation. That radiation we can say that H nu or photons. Same here. So now it is clear that absorption means what? Absorption, the spectrum produced by the absorption radiation. Absorb radiation is called absorption spectrum. Here see, for example, once more I am telling about that when the electron from an atom absorb energy from the surrounding reaches to higher energy level. Okay, from ground level to ground level to immediately where, that is the higher level to jump. Then absorbing energy result, it is we will get continuous spectrum also, but with the dark lens. So that is you have to remember that what is atomic spectrum. Look at the image also, we will discuss later. Next is emission spectrum. Here emission spectrum means what? The spectrum produced by the emitter radiation. What do you understand from emitter radiation? Whenever white light or electromagnetic having interact with an atom or molecule, here we learn the electrons are some energy absorbed from lower to upper. Same case from upper to down, some radiation, some these electrons are coming back. Okay, so again it will emit some radiation. Okay, this emit same radiation we can say that H nu or photon. Okay, now it's clear what is absorption and what is emission. Absorption spectrum produced by the observed radiation is called absorption spectrum. Next is what is emission spectrum means. Spectrum produced by the emitter radiation is known as emission radiation. Okay, is it clear? Now we'll go to next slide. Okay, in this one, what did you understand from this just now we learned what is continuous spectrum, what is absorption spectrum, what is emission spectrum. So just you see these three spectrum, what did you understand? In this case, first one is continuous spectrum. Already we know that when the white light or radiation is passes through a prism, a spectrum can be observed consisting of different colors, okay, which would be termed as a continuous spectrum. But when the electron from an atom absorb energy, okay, from the surrounding and reaches to higher energy level from the ground, it come back to ground energy of releasing of energy which is not continuous. This is actually what happened, not continuous spectrum. Compared to continuous spectrum, it is not continuous. It will be between some lines are there. So these black lines, we can say that it is absorb some energy, the particular wavelength. That is we call it as absorption spectrum. The emission spectrum means we can see that the different lines color lines, the background is black. Okay, this is the gap is there. That means it is that these are the color lines emitted. So we call it as emission spectrum. Now, what is absorption spectrum? Just now we learned that when the light emitted from a source is made to pass through an absorbing material, then examined with a spectrometer. So we need actually here spectrometer. Then only we will get the spectrum. Okay. So the obtained spectrum is called absorption spectrum. Even this absorption spectrum also there are three types is there. One is continuous spectrum is there, lines absorption spectrum is there, and band absorption spectrum. So clear now? There it is absorption spectrum also three type, continuous, line, band is there. So in this case, even absorption spectrum we can say that each spectral line, okay, in particular wavelength it is there. For example, we will take it as spectrums. In this spectrum, each spectral line corresponding to one particular transition between energy state of the level is there. Okay, whether the absorption line occur, in this case here what happened, absorption line. So these absorption line occur when the electron jump from lower energy to higher energy. It's clear now? You have to remember how these black lines are coming from absorption spectrum means the absorption line occur how the electron jump from lower energy to higher energy. Okay, so it produce some radiation. This is we can say the absorption spectrum. Even emission spectrum means from higher energy level to again it is coming to stable their particular energy ground state. Then we can say that this is the emission line spectrum. Even if you were to observe the star, so in this case we can say that again this example, observe the star directly, you would see a continuous spectrum is there with a no break. So here also, instead of the bulb I am using suppose sunlight, it is what happened, it is a continuous spectrum is there. So without break, any lines, nothing is there. Okay, that means no disturbance, nothing is there. So we can say that directly we are observing. Then it is called continuous spectrum with the no break. That is the very point with the no break is there. Between no line and no dark line shade, nothing is there. Next is here, if you observe the star, same star or sun through the gas, okay, any gas, hot gas. Here I am taking here, one is hot gas, one is cold gas. So you will see a continuous spectrum with the break. Okay, here also continuous spectrum is there, but with the break is there. Okay, which is black. Some places are black shade is there. Where the what is the meaning of why it is getting here also break is there, but here absorption black line, here emission colorful line, but some gaps are there. Why it is coming this one here? The specific wavelength of energy have been observed by the gas. What is that cloud? Atom. Okay, so maybe it will be observed. That means it is the observed means particular wavelength. It is observed means that is it is make the dark line. We can say that absorption. Here some lines are what happen. It will be re-emitted. Then we can say that this is emission line spectrum. Clear? Now, even just now we learned what are the three type of absorption spectrum: continuous, line and band spectrum. Now we will discuss what is continuous absorption spectrum. That means see why we here why we are using this spectral line first thing. Okay, so why we are studying about this spectrum means used to identify atom and molecules. Okay, so that is we are using whether what is continuous spectrum, what is line absorption spectrum, what is band absorption spectrum or different purpose. So here the main difference between suppose emission and absorption spectra is that an emission spectrum has what different color lines are there in the spectrum, wherein absorption spectra has dark color lines in the spectrum. You have to remember these 3 points. Now again we are coming back again what is continuous absorption spectrum mean. For example, if you take a pure green glass plate, Okay, when placed in the path of white light. So here I am using white light. Then again green colors are there. In this case, so this arrow, what did you understand in this one? It is observing everything. Okay, all the colors are observing except green. So that's the reason we can, what is it is reflecting. Okay, it is reflecting only green. So we can say that this is continuous absorption spectrum. Next is line absorption spectrum. In this line absorption spectrum, when light from the carbon atom. So here I told you that different what is that we are using different means testing. Okay, testing atoms or identifying the atoms or molecules or different gases. We are using different lines or we are different spectrum we are using. So when light from the carbon arc is made to pass through the sodium vapor, then examined by a spectrometer, the two dark lines. See, look at this image, this spectrum. What is the specialty here? Carbonate through the means sodium vapor lamp. We are using here spectrometer. So through the spectrometer only we can see the spectrum, is it? So in this spectrometer, what we are means observing here. Yes, here the particular yellow region we can see that two dark lines. So we can say that this is a line absorption spectrum. This more detail you can study in the higher classes. Next is band absorption spectrum. So even the band absorption spectrum, if white light is allowed to pass through the iodine vapor or dilute solution of blood or chlorophyll or through certain solution of organic and inorganic compound, dark bands or continuous bright backgrounds are obtained. Okay. So see here, what is here band spectra? Band spectra is a name given to group of lines. Okay. So we have to remember that what is band means, always you see the spectrum, that is you will get the group of lines, whether violet or red, or we can see that group only. It means number of lines grouped together closely spaced that each group. So nitrogen means spectrum band also we can say. Different means gas we can observe that nitrogen, and so whatever it will be the group that we can say that band spectra. Even band spectra we are using means making dyes. Next is emission spectrum. So in the means just now we learned about absorption. Now the emission also. In this case here, when white light is emitted directly from the source with the spectrometer, the emission spectrum is obtained. Okay. So that we know that the spectrum produced by the emitted radiation. So whatever the emission emitted the radiation we call it as emission spectrum. Even see each element, for example, why we are studying the continuous emission spectrum, line emission spectrum, band emission spectrum, these are all the types of emission spectrum. There also there it is the words are same, continuous welcome, line and band. Okay, there we studied continuous absorption spectrum, line absorption spectrum, band emission spectrum. Instead of absorption we are written here emission only. Okay, so the types are this means different purpose we are using. So here each element has its own unique line emission spectrum. So did you know that actually just the way fingerprint are used to identify people? Okay, same there. The characteristic line in an atom. So each particular emission or absorption, we will get some lines in an atomic spectrum are used to what? Identify unknown atoms. So some atoms are we don't know, even some gases also we don't know. So we have to what we have to do to identify. That is the reason we are studying the different spectrums. So in this we know that continuous spectrum. In this here look at this image, what happened here, unbroken luminous bands of all wavelength containing all the colors from violet to red. Okay, This spectra depends only on the temperature of the sources. It is independent of the characteristics of the sources. Even where we are getting the continuous spectra means produced by liquid, carbon arc, incandescent solid, electric filament lamps also gives continuous spectra. Next is line emission spectrum. That means here also just now I told you there it is. Line spectra are produced by what? Atomic substance, such as we are using here sodium in a sodium vapor lamp, mercury in a mercury vapor lamp, and gases in the discharge tube. We have to means how we are producing the line spectra. Next, line spectra, look at this here, means here sharp lines are there in definite wavelength. Okay, the particular wavelength we can see that is we can say that line spectrum. The line spectrum means each means from violet to indigo, blue, green, whatever the colors here, that is the each lines having, we know that different wavelength are there. Okay, so these are the lines. For example, green, what it is there, it is a particular wavelength, it is a emitting substance. So that particular matter, it is emitting this wavelength. Okay, this the particular wavelength is a green, that means green it is identified, we know that the green wavelength. So even it is used to identify, usually this line spectrum is used to identify the gas. Okay, clear? Now band emission spectrum, we know that it is obtained from various line spectrum only. Even the group of the number of lines merged together and close together, that it is each group. This all, see, you can look at here, these are the green also, it is a group, it is there. So that means here calcium and barium salt in a Bunsen flame and gases like carbon dioxide, ammonia and nitrogen in molecular state in the discharge to give band spectra. So where we are getting the band spectra means this particular, even the chemistry lab you can try this using calcium, barium salt and Bunsen filament also. Okay. Next is here using band spectra. Why we are using that? What is the purpose of using band spectra means we can study molecular structure of the substance can be studied. Okay, molecular structure, the particular atoms. So we can study detailed molecular structure of the substance can be studied. Which one? Band emission spectrum. Hope all are understanding. Thanks for watching.